All right, we are the single line diagram. Just going live on a few different platforms. I haven't gone live in a little bit, so I decided to take this time to talk about the single line diagram. We're going to do a 15-minute tech talk on single line diagrams. Very important aspect of power systems engineering. I'm a power systems engineer by training, by education, by practice. My background is in power systems engineering, and I leverage the one line diagram considerably in what I have done in the past. I don't do power systems analysis as much anymore, but I used to do that a lot, and I'm realizing as I got into the whole discussion of codes and standards in the world of 70E and the National Electrical Code, and now I sit on NFPA 70B for maintenance. You realize more and more that the single line diagram is a critical piece of the equation for a lot of individuals associated with electrical safety. So I thought I'd do a 15-minute tech talk on this topic of the single line diagram. I know I've talked about this before. Let's see how close you get to 15 minutes. Yeah, Steve, Mr. Froming is in the house and reminding me that I've never hit 15 minutes. Not yet. My very first one, I was very diligent, and I come pretty doggone close. But we're going to try this time, Steve, and I haven't started the clock yet. There it is. So I'm just checking to make sure I've got everything going. I am live on my YouTube. I'm live on Facebook, and I posted to my LinkedIn account. And we will go. I'm going to add Tyler Yonker to my LinkedIn account. He is a sales engineer at Zatkoff Seals and Packing. So, Tyler, if you are watching this right now, I just added you to my LinkedIn network. Welcome aboard, Tyler. So let's get this party started. And we're going to start the clock. And I'm going to hit the button, it's Mr. Froming, and you're going to keep me honest here, but when I hit this button, I'm going to add 15 minutes to that clock, and we're going to see if we hit it. Welcome to our 15-minute tech talk on the single line diagram. Very important topic for electrical safety, and as we walk through this next 15 minutes, I'm going to hopefully raise the awareness with all of you as to how important the single line diagram is to not only the power systems engineer, but also the electrical worker and the facilities manager for any facility that you're involved with. I will reference some National Electrical Code, NFPA 70E, and NFPA 70B references for you, because what we have to do as an industry is help those who are control of the budgets. Because if you think about the one-line diagram, somebody has to spend some time in developing it and maintaining it. And if you don't understand the value of that important document, then it's going to be hard to justify to anybody the money and resources that it will take to keep this on your radar. So the single line diagram, I liken it to a roadmap. So if I sat down and told you that you need to get to Weirton, West by God, Virginia in 2 weeks from today, can you get there when this is your roadmap? And I don't tell you anything about where Weirton, West Virginia is. But then you appeal to me and say, Tom, I need a general direction. And I tell you, well, here you go. Here's your roadmap. You're in Oklahoma, and West Virginia is right over here where that golfer is. Head towards the golfer. Is that going to get you to Weirton, West Virginia? Probably not. What if I gave you a map that looks like it was from the 1950s? Okay? Do you think that those roads are all still there? Do you think that maybe there are some new roads that you may consider to get you there a little faster? Probably. So the one-line diagram has to be a document that is that exists for you to understand your roadmap through your power distribution system in your facility. And it can't be something that's antiquated and old, because it could be out of date. And the information that you need has to be more up to date. So if I told you I'm going to give you an app that's going to navigate you on the latest roads, and any of the roads that are no longer there, you're not going to be able to go use. And if you want to avoid tolls, I can get you to Weirton, West Virginia by avoiding tolls too. Just don't come from the airport, because there's 75 cents. I think it's $1.50 now. I mean, last year was 75 cents. Now it's $1.50. But in any case, the one-line diagram, it's important to keep it updated, because the one-line diagram is your roadmap to the power distribution system within your facility. So let's talk about the role of the single line diagram. Now, I'm going to use these words interchangeably. I will call it a single line diagram. I will call it a one-line diagram. Why do we call it a one-line diagram? Because there's such thing as a three-line diagram. Three-line diagrams show phases A, B, and C. They'll show you the CTs in A, B, and C. They'll show you the breakers in A, B, and C, the contact parts. They'll show you a lot more details. They'll show you the current transformers and all of a lot more details than a single line diagram will give you. A single line diagram is used for short circuit calculations, selective coordination studies, load flow studies. I throw safety evaluations in there, because safety is a critical role to know what I need to turn on and off, or hopefully turn off, to establish an electrically safe working condition. I might rely on a single line diagram to let me know what's upstream. Any of your engineering studies are going to start with a single line diagram. Your safety procedures are going to probably start with a single line diagram. You need your maintenance. You need to know what is where in your power distribution system. You need to know what it's serving to understand how often maybe things are turning on and off, how often your different components in your power system are getting leveraged. So I am going to use single line diagram and one line diagram interchangeably throughout this presentation. So just be mindful of that. I'm meaning the same thing. I'm going to reference 3 key documents that we use for safety. And I consider this the trilogy. 70 is your National Electrical Code. That is your installation requirements. 70B is your maintenance. So I install things per National Electrical Code, this 70 document. I maintain it with 70B. And then I have to rely that I've installed the right stuff, I've maintained it properly to establish an electrically safe work condition through leveraging the standard for electrical safety in the workplace in 70E. So all of these documents play a critical role, and the one-line diagram is mentioned in all 3, but I will argue with anybody who says that it's required, that there are no actual language in any of these documents that says thou shalt have a single line diagram. But, that leaves to be explored in our next 9 minutes and 4 seconds. All right, so single line diagram is defined in the National Electrical Code as a diagram that shows by means of single lines and graphic symbols the course of an electric circuit or system of circuits and the component devices or parts used in those systems. So you're going to see things on the one-line diagram like your transformers, your conductors, your big boys, your big hitters. You're not going to see every terminal block or things of that nature. You're going to see panel boards, switchboards, all of your electrical distribution equipment. You will see, hopefully, details about those items. Now, what I'm showing here is a one-line diagram that has, your 15 kVA, 1500 kVA, 4160. I'm showing voltage right next to this symbol. It could be that your one-line diagram doesn't have all of the information right next to every component. There could be tables. In fact, you could have a reference diagram that says all of your transformers are on this other drawing. And this is transformer T1, and the other transformer down below is T2. and you go to this other document and it tells you T1 is a 1500 kVA transformer with 5.75% impedance, and the primary and secondary voltages are 4160 and 480. And it could give you manufacturer, model number, and all these other details. But suffice it to say, you know what that transformer is by looking at this set of drawings. So a key thing to note is a one-line diagram might not be one specific drawing for your entire facility. It could be a whole booklet of drawings depending upon the size of your facility and the detail that you want to place in association with that single line diagram. You see on this diagram that there's overcurrent protected devices called out. The available fault current is called out. Oh, that's an important parameter to put on a one-line diagram. And I like to have it, I always used to put the available fault currents on the single line diagram next to each bus or each piece of equipment down to which I calculated that number. I would put the three-phase bolted fault. That's typically your maximum. Your single line to ground fault currents could be higher than your three-phase bolted fault. Suffice that to say, but you will want to put your information of your available fault currents on these one-line diagrams and the date that you updated those. So you'll want to make sure you date the one-line diagram. I mean, not to take it out to dinner or something like that. I want you to put the actual date that you drew that diagram and you verified the data was accurate. Put that on the diagram. Hey, Nihad, thanks for joining me, buddy. You and Steve Froming in the house. So you'll want to identify motor loads, and you'll notice I just have M for motor. Typically we'll put horsepower motors, or if I group a bunch of 20 horsepower motors together, I'll lump those together and say this is a lump of X amount of horsepower of a group of 20 horsepower or less motors. So you're going to want to put that type of information. Transformers, motors, and your conductors. So that's the other thing. The conductor is the glue to the entire facility. If you don't have a conductors, you're not connecting anything together. This is just electrical equipment in a warehouse, right? So your conductors tie everything together. You're going to want to know the length of those conductors. And typically, we put that information in a separate little table. And sometimes you'll see that. You'll see the one-line diagram, and then you'll see a little table with, C1, C2, C3, the conductor designations, and then we'll have all the details because you'll need to know number of conductors in phase, in each phase. You're going to need to know the material, copper or aluminum, the insulation type, not installation, but insulation. You'll need to know whether it's a metal raceway, PVC, or what type of raceway it is. What else? The length of that conductor and the voltage ratings of those conductors. So as much detail as you can provide, the better off you are. But those are some of the key parameters that you'll need for things like short circuit studies, motor starting studies, and things of that nature. Okay. And then in your panels, typically the information, some of that information might be in your panel schedules. Okay. So in a panel schedule, you might have all of those, your HVAC loads, which are too small to be putting on a larger one-line diagram. You'll go down to the panel board, and then you'll rely on the panel schedule to give you the detail on the loads associated with each of those, whether it be lighting load and things like that. But your one-line diagram, that's the beginning, and that's where it all starts, because just as these two individuals are doing, you're going to be looking at that one-line diagram maybe out in the field. I remember we were doing a plant. I was doing a study, a short circuit study on an Alcoa plant down in Tennessee near Knoxville, Murraysville, whatever. And I was walking around a facility looking for a motor control center, and I could not find that motor control center. I was all over the place, and there was an electrician sitting on a bench, and he was eating a sandwich, and he looked over and he says, "Boy, what are you doing?" I said, he goes, "I've watched you pass me 7 times in the last 30 minutes. And I told him, I'm looking for MCC, 3AB or whatever the number was. And he said, "Let me see that drawing." And he grabbed the drawing and he says, "Heck," he goes, I don't remember that being here." He says, "I remember we did a project a long time ago where we removed an MCC, and that might be it." And he looked down at the date, and the date was like, it was 10 years old. The one-line diagram actually was probably older than that. And he goes, holy cow. He says, yeah, that was the motor control center. And we removed that about 10 years ago. That drawing that you're looking at is not up to date. Now, I was supposed to do a short circuit and a coordination study for this facility. And I was supposed to be using the single line diagrams that they gave me, which were 10 years old, which were obviously no longer accurate. I can't do a short circuit study, which then would have been a coordination study. And that was pre 1584, IEEE 1584. But today we would be doing an arc flash analysis. You've got to make sure that the single line diagrams are up to date. That includes motor contribution, conductor lengths, utility contributions, all of that information, which is pertinent for calculating fault currents, which is the start of many studies. Selective coordination and arc flash being two critical studies that you will need to perform. And you've got to have the right information. So what do we show on a one-line diagram? I got 2 minutes left. I don't think I'm going to do it, Steve, but I'm going to try. Incident energy at this location. So what do we show? What do we show on a one-line diagram? So let's just walk through that. I need to know the transformers. I need to know their size. I need to know their impedance. I need to know their voltages, primary and secondary. I need to be able to calculate full load amps. I need their impedance values because I need to be able to calculate the fault currents and plug that information into software applications. I need to know the length of conductors, the impedance of those conductors, the length of the conductors so I can come up with the impedances, the size of the conductors, the number of conductors per phase, whether they're aluminum or copper, the raceway that they're in, whether it's metal or not. I need to know the motors, size motors, the subtransient reactance, hopefully, of those motors, because I need to model those in my power distribution system. I need to know the voltage of those motors. I need to know the subtransient reactance at what voltage, because I might need to change that subtransient reactance based upon the voltage that I'm applying that motor at. So there are a lot of details associated with those motors that I'll be able to, that I'm going to need, again, depending upon the size. We don't do that for 20 horsepower and below. When you get into those nice big hefty motors, I'm going to need more information. The bigger they are, the more data I will need from a power systems analysis perspective. So motors, transformers, conductors, busway. If you have busway, what size busway? What's the manufacturer? You would want to know the manufacturer model numbers of as much of the equipment as you can, and we should have as-built drawings. So yes, the one-line diagram starts in the world of design before we bid, but that one-line diagram has to have and be kept up to date as we move into the build and design build phase. Well, Steve, I've blown my 15 minutes out the water, but that's okay. We're going to continue on our journey. So here's a case example, importance of a single line diagram. You're going to work on a panel, and maybe it's labeled or maybe it's not labeled. So in this case, it's the first panel board on the secondary of a transformer. If it is labeled, I'm going to see 23.5 calories per centimeter squared. I need to know that this panel board is that first device, that first panel or first piece of equipment on the secondary of a transformer. That piece of equipment is always going to have a high incident energy. I'm going to need, if I'm following 70E, I'm going to need to go upstream to calculate that, to determine the table methods. So I need to know what breakers are feeding what. If for example, my next upstream device is actually a breaker in a box, a single breaker with a disconnect, and then I'm going to need to know where that's at and the fact that it's there, because now you'll notice it without that separate enclosure, I'm at a very high calories per centimeter squared. But if I have this secondary overcurrent device in its own enclosure, I don't have to worry about line side propagation. I can leverage the clearing time of that overcurrent protected device. Now I know my incident energy is going to be less, much less, even if I'm using the table method as well. Fusible disconnect. I had to throw that in there for my busman boys and girls. The single line diagram is your roadmap to get your final destination. Without that in a power distribution system, you are lost. Let's take a look at 70E. 70E offers a definition, a diagram that shows by means of a single lines and graphic symbols the course of the electric circuit. Why do I need to know that course of the electrical circuit? Tell you why. Because I have lockout, tagout procedures in 120.2. The definition doesn't have a requirement. This section 120.2c, lockout, tagout procedure, tells us that we have to do lockout, tagout, developed on the basis of the existing electrical equipment and system, and shall use suitable documentation, including up-to-date drawings and diagrams. It says it shall use suitable documentation, including. It doesn't say you shall have an updated one-line diagram. So I think it could be a lot more solid to say you really need a one-line diagram, and it needs to be up to date. 70E hasn't taken that step yet. They're very indirect references like this. Look in 120.2, lockout, tagout principles. E says electrical circuit interlocks. Documentation, including up-to-date drawings and diagrams, shall be reviewed to ensure that no electrical circuit interlock operation can result in re-energizing the circuit being worked on. We do that with one-line diagrams. It doesn't say you shall have an up-to-date drawing and diagrams. It just says you should use documentation, including up-to-date drawings and diagrams. So it's not solidly saying you got to have it, but you got to have it to meet these requirements, in essence. So these are good argument points. If somebody's arguing with you, why would we need to update them? Go back to 70E, point these specific areas out in this document, say, look, how am I supposed to do this without this up-to-date information? We need to budget for this. We need to make sure it gets done. 120.5, process for establishing and verifying an electrically safe work condition. You have the following steps. Determine all possible sources. If I don't have a one-line diagram, how do I do that? And it tells you, it's had to be up to date. After properly interrupting the load, open the disconnecting devices for each source. If I don't know where those are, I can't do that. Visually verify that all the blades, I don't need a one-line diagram for that because I'm looking in the equipment. 1 and 2, you need a one-line diagram. I'm sorry, you need that. 120.5, process for establishing and verifying an electrically safe work condition. Release the stored energy. Release blocked stored mechanical energy. Apply lockout, tagout devices in accordance with documented and established procedures. Okay, all of these things, I need good one-line diagrams and documentation and up to date. 205, now we're moving into general maintenance requirements in this document. Single line diagram, where provided. I wish it said a single line diagram shall be provided for the electrical system, but it says where provided. Shall be maintained in a legible condition and shall be kept current. So if you have a one-line diagram, you've got to keep it current. I would argue you should have a one-line diagram. And I know what you're going to say, Tom. I look forward to your public input. But there were public inputs on this. Check it out. They were rejected by 70E. And hopefully one day they will embrace that single-line diagram. Whoop. Employer now. 340, specific measures for personnel safety, employer responsibility. It says the employer shall be responsible for the following: proper training and supervision to properly qualified persons, so we know that. Identification of associated hazards. Strategies to reduce the risk associated with those hazards. Methods of avoiding and protecting against the hazards. And finally, you get down to 6, so that's item 1. Let's take a look at 6. Let's get me out of the way. Provisions of complete and accurate circuit diagrams and other published information to the employee prior to the employee starting work. They need those single line diagrams. They need that information before they get to work because they have to understand how to create an electrically safe work condition. And if you're looking at a document that's 10 years old, you don't know if you're turning off the right switches because a lot can happen in 10 years. Look, I started the 15 minutes over again by mistake. That's okay. Look, I got 14 minutes left, Steve. All good bonus, I know. All right, so here is in E3. Now, this is annex material E3. Now, I have a special 70E document. Now, watch this. This is what's special. You ready? Hold on. Hold on. Look at that. I think it's rare, and I think it's going to sell for millions of dollars on eBay. The cover was put on upside down. Or it could be that the contents were put in upside down. I don't know the answer to that question. I'm investigating it as we speak. So if you look at Annex E, remember, Annex material is not enforceable, but Informative Annex E's title is, drum roll please, Electrical Safety Program. And if you look at the Electrical Safety Program, one of the items that they identify, it says Electrical Safety Program procedures can include, but are not limited to, determination and assessment of the following. And the electrical single line diagram is number 9. So very important piece of the electrical safety pie for the electrical worker. Now, let's move into maintenance. Another very important thing. Why is maintenance important for the electrical worker? If they're going to rely on an overcurrent device upstream to open, it better open when they need it to open, because they're relying on it to clear energy. If they're going to rely on a disconnect switch to open when they hit that handle and not cause a hazard in itself, it better do what it's supposed to do, how it's supposed to do it. 70B is critical. In Chapter 6 of 70B, Planning and Developing an Electrical Preventive Maintenance Program, look what it says. The work center of each maintenance work group should be conveniently located. This work center should contain the following: copies of the inspection and test procedures, copies of previous reports, single line diagrams. Now, finally, I hit the mother lode. The work center must include the following. It doesn't say, well, it says should. I didn't hit the mother lode. I was thinking, boy, there it is, a shall. But in reality, 70B is not a shall document yet. Stay tuned for that one. 6.2.2, diagrams and data. The availability of up-to-date, accurate, and complete diagrams is the foundation of a successful EPM program. The diagrams discussed in 6.2.2.1 through 6.2.2.8.2 are some of those in common use. So the one-line diagram is critical. It has to be updated. Here's a 6.2.2.1. The single line diagram should show all electrical equipment in the power system and give all pertinent ratings. That's pretty comprehensive. We don't put all electrical equipment. We are selective. Your one-line diagram would be unreadable at that point. So you got to think about that in regard to how much information, but you got to have the right information. There's some guidance here that's provided. The voltage, frequency, phase, and normal operating positions should be included. No less important, but perhaps less obvious, are items such as transformer impedance, available short circuit currents, all overcurrent protective device types, ampere ratings, settings, interrupting rate. There's a good one. What I used to do was put the settings in a separate table. So if I had electronic trip units, I would put the settings based upon the selective coordination studies, so that when you grab that one-line diagram or that drawing, you roll that puppy up and you head out to the plant, you should be able to walk in, look at a panel board or switchboard, open up the table, see it has electronic trip units, and then you can look to make sure that the settings were programmed correctly on those trip units. Again, very important aspect of safety. Now, the National Electrical Code, a little weak on the one-line diagram, just saying. 490.25 says installations where the possibility of backfeed exists shall comply with A and B, and A says a permanent and legible single-line diagram of the local switching arrangement, clearly identifying each point of connection to the high voltage section. So you'll see these plastered in your medium voltage rooms, etc. I believe that's the only reference that I can find. That's in Article 490 in the National Electrical Code. So here, my bottom line is the one-line diagram is an important tool. You use it for short circuit studies. You use it for coordination studies. There are a lot of different applications where the one-line diagram is used from a power systems engineering perspective, as well as from a perspective of electrical safe work practices. So in this little, 15 minutes plus, in this 30-minute session, I gave you some good references so that if you have the situation where you need to defend paying somebody, it could be an internal people keeping this up. You don't have to hire somebody externally. If you have the right qualified individuals internally to your organization, maintaining that single line diagram is not that hard. In fact, I would argue that you should have somebody in your facility responsible for maintaining that one line diagram and intimately involved with the maintenance of that diagram, because that individual is going to know that power distribution system in your facility like the back of their hand. That is going to be their ability to. They're going to be the go-to person should you have to do some maintenance or do any work in the facility. That's going to be your go-to person that says, they know that facility, they know what's up to date, they know what has been modified or changed or whatnot in that facility. That is going to be your reference, your resource to make sure that the electrical work is being done correctly, and any planning that you're going to do is planned correctly, because they're going to have their arms around that power distribution system. So this little 15-minute plus tech talk with a little bit of bonus material, as Steve Fromming calls it, is important. And I think, I'm not sure, Steve, what BC, BVB, GB, I don't know what that is. I don't know what you're saying there, buddy. I don't know if you went, he's sorry, it typed while in my pocket walking to the truck. You shouldn't be walking and watching YouTube at the same time, Steve. You can't chew gum and walk at the same time. Jeez, oh man, I'm going to worry about you now. Gosh. Well, I appreciate you watching, though, and providing feedback, buddy. It's clear as mud, right? Just be mindful. That single line diagram, think about it. We create the single line diagram to do bids on projects, to come up with what equipment that we need. And we'll use ballpark figures, right? I may not know the conductor lengths in my facility that I'm designing that hasn't been built yet. I don't know the percent impedance of the transformers because I haven't purchased them yet. I'll grab, based upon whatever manufacturer, I'll grab their minimum fault current or their minimum impedance values and take estimated guesses so that I can make sure that I pick the right devices. If it's selective coordination as a requirement and I'm using circuit breakers, I need to know fault current values, which is going to be dependent upon conductor lengths, impedance of transformers, things of that nature. I'm going to make some assumptions that will not put me in a bind. If my assumptions were wrong and my impedance values came in different or my conductor lengths came in different, I don't want to have to go, oh crap, I have to go and buy a bigger breaker or a more expensive breaker. My bid is gone south on me, and I'm starting to eat into profit. So you're going to want to make some assumptions, but that one line diagram will be given birth to during the bid process, but it needs to be maintained and continued to be updated into the as-built phase so that our electrical workers, our power distribution engineers, power systems engineers who are going to do other studies are referencing accurate information. So be mindful of that. Hopefully this little session gave you a feeling for the importance, not just from a systems analysis, but from the electrical worker's perspective, that one-line diagram is a critical piece of the equation. Don't sell it short. defend it when someone says we need to cut budget, not dollars. You don't want to take it out of the one-line diagram. Please don't do that. For safety's sake, for your electrical worker's sake. All right, they'll love you for it. The electrical worker will thank you the next time they're planning and trying to establish an electrically safe work condition using that document. They won't cuss you out because it's not updated. Like I did that day. I turned that one into more money because I went back to the client and said, look, I'd love to do this short circuit study and coordination study, but did you know that this one-line diagram hasn't been updated for 10 years? And did you know I've identified at least 3 pieces of equipment that no longer exist in that facility? And I was able to get another order to update that single line diagram. But it was not inexpensive because it's a lot of man hours to walk through that facility and see what's there and what's not there. So, especially a large facility. Thank you for watching this 15-minute Tech Talk. I'm going to get rid of that 15 minutes because it's driving me crazy. It's now down to 10. It's my second round. So we got Nihad El Sharif out there, Steve Frobing, walking to his truck. Hopefully he's not watching this while he's driving. He was probably going there to get his personal protective equipment because he's going to go inspect something, right? On Facebook, I ain't got nobody on Facebook. That's okay. I love you still. It'll be out there. So in any case, thanks for watching. And it is Beer 30, 5:38 my time here in Weirton, West by God, Virginia. Stay safe, stay healthy, and if you have questions on a one-line diagram, please reach out to me. And on your next project, if you don't have the resources, there are many people out there would love to keep those one-line diagrams up to date for you. Yeah, so Nihad, we'll make it the 30-minute Tech Talk, but 15-minute Tech Talk sounds so much better than 30-minute Tech Talk. Put it this way, if I blew 15 minutes out of the water, I'd probably blow 30 minutes out of the water. And then it'd become a 60-minute Tech Talk. And then I'd probably blow that one out and be a 2-hour Tech Talk. So it just gets worse. So anyway, thanks again for watching. Thanks, Nihad. Thanks, Steve, for tuning in. And anybody else out there, remember, hit the subscribe down below. Leave me some comments, questions, concerns, or anything. If you want to see a 15-minute Tech Talk on some other topic, let me know what you want to talk about. And don't forget to hit the bell, because if you hit the bell, you'll get notified. Don't forget to subscribe or send me a friend request on Facebook. Send me a LinkedIn friend request. Let's connect out in the social media world. Remember, too, Western Section meeting is next week live. We created a Western Section YouTube site. We are going to have a great lineup next week. So this is just a plug for those of you who are going to watch this and have stuck around to the end. Thank you. This is your real bonus, is that you have the ability to sign up for the Western Section meetings. Check that out I put it out on my LinkedIn. I'll put a link down below to the week-long registration for that as well. It's going to be a YouTube experience. We've got a lot of great talent, knowledgeable individuals who will be presenting. All right, buddy. Take care, stay safe, and please stay healthy. Signing off this 15.5-minute Tech Talk. My name is Thomas Dimitrovich. Thanks for joining in.